Okay. Last time we were doing exponential functions, right? So
Mm-hmm.
now we're gonna do applications of exponential functions. I guess we did kind of talk about it when we did the half-life thing and population growth, exponential equations, but we're actually gonna do some real life things where you can use this. And this is called finance, okay? Financial applications of exponential functions. So how does this work? So look at this. So let's say this is the bank. Yeah, this is the bank. You put money in this. Okay, you
Mm-hmm.
put maybe $1,000. You're lending the bank your money. What happens is, in return, because you did this, you're gonna earn some money back. They'll pay you something called interest. Okay, and then when it comes to
Uh-huh.
interests, there's two types. One of them is simple interest, where, for example, if you put $100 in, every year maybe you get $10. Every year you get $10. Okay. So after 1 year, you'll have 110, second year 120, third year 130. The other type is called compound interest. And how does this work? A little bit differently. The first year, you're still gonna get $10. In total, you'll have 110, but the next year you'll get 10% of this. You'll get $11 and you'll have 121. Next year, you'll get 10% of this. You'll get $12.1 and you'll have what is this? 132.1, like that. So compound interest, you earn money on the interest itself. Simple interest, no, you only earn on the initial deposit, okay? Two types.
Mm-hmm.
And we're gonna look into both of these in detail. Let's look at this one. First one's gonna be simple interest, and simple interest is pretty simple. In fact, mathematically speaking, simple interest is a linear function. It's gonna be linear. The money that you earn, it's gonna be constant. How do we know it's gonna be linear? Because you earn the same money every year. It's constant, like the slope. It's a linear function. Whereas the other one, compound interest, is exponential. Let's look at this question. So this individual invests $30 to $40 at 2.4%. You see that notation there, percent slash A? This
Mm-hmm.
means per annum, okay? Per annum. Annum means just per year, another synonym for that. So
Okay.
they earn 2.4% per year, simple interest. Calculate the interest earned each year. So to do part A, how do you find the interest? Well, the interest is simply this. Interest is equals to the interest percent in decimals. Yeah. So this I here represents the interest in decimal. Then you just multiply this with the principal amount, P. And P is the amount that you put in initially in the bank. Okay, this is the initial amount that you put in. So to do part A, we're just gonna do I, which is 2.4%. And again, change that to a decimal by dividing by 100. And we'll just multiply this with the principal amount, okay, like that. So what
Okay.
is that gonna give us? 0.024 times 3240. That gives us $77.76. And that's the interest the person earns each year. Part B, calculate the amount and the total interest earned after 20 years. So how much interest will, if they earn this much per year, yeah? After 20 years, how much will they earn? Just in terms of the interest.
You just multiply.
Just multiply that by 20. So the total interest over 20 years is just going to be 77.76 times 20, which gives us $1555.20. So this is the total interest, yeah?
Mm-hmm.
But then also remember that we had our initial deposit. So this question is basically asking you how much money is there going to be after 20 years. So they're going to earn this much interest. And then again, we're going to add this with the initial amount. And that's going to be the total bank balance after 20 years, which is $4795.20. Cool. So
Mm-hmm.
the interest is this, and the total amount in the bank after 20 years is this. Part C, determine the formula for this. It's asking us. Now, what's the formula for simple interest? You can kind of decipher that with what we just did. So the formula for interest, okay, the total interest is gonna be PRT. Now, what does all of this mean? T is a time in years. P is a principal amount, the initial amount, and R is a rate in decimal, okay? R is a rate in decimal. So that's the formula for the total interest over whatever time. What about the formula for the total amount? It's going to be the initial amount that you put in, principal, plus the interest, right? PRT, and there we go. This is a formula for simple interest, where A is the final amount in the bank, P is the principal amount, which is the initial amount, and then PRT is your interest, where R is the rate, and T is the time, okay, in years,
Okay.
You can even factor a P out here. Sometimes you'll see it written as this, 1 plus RT. This is the formula for simple interest. Cool. Let's see some more questions now that you know what the formula is. Tina borrows $15,000 at 6.8% simple interest, and then she plans to pay back the loan in 10 years. So the question is, how much will she have to pay back after 10 years? So let's look at the formula again. The formula for simple interest, the final amount is going to be P bracket 1 plus RT, yeah? What's given here? We know the principal is 15,000. 1 is just 1. What's the rate? What's that in decimals? What is 6.8% in decimals?
0.068.
Yeah, 0.068. And time, we know it's just 10 years. So just multiply this by 10, yeah? So what does that give us? So 15,000. Do you have a calculator? Why don't you start plugging that in?
It gives me 1.68.
Okay, and then you got to multiply that by 15,000. It should give you, actually, yeah. And then you multiply that by 15,000, yeah. See the 15,000 on the outside? What does that give you? It should give you this. You just multiply 1.68 by 15,000. Okay. What does this represent? This is the amount she will owe. She will owe this amount after 10 years, okay? After 10 years. So how much does she have to pay back in just interest? What's the interest over 10 years? To find the interest, well, you just subtract the final amount that she pays back minus the initial amount she borrowed, yeah? Let's look at what all these letters mean. P is the initial amount that you put in the bank, okay? And or you borrow from the bank, and after a while, you either earn interest or you have to pay back interest. These two combine to make the final amount, okay? Principal plus interest is the amount. So if we're just trying to find the interest, we can just subtract the final amount she pays back, 25,200. How much does she borrow to start off with? 15,000, yeah. So she pays $10,200 in just interest. See that? That's pretty high. So how much does she pay every year, each year? Well, you just divide this by 10 because there's 10 years. So you get 1020. So every year she has to pay $1,020 in interest. Okay. So this you won't find it. Banks don't do simple interest. People do, like if you borrow it from someone, they will do simple interest. Usually, I guess. If it's a friend, probably no interest. But if you borrow it from the banks, they usually do not do simple interest. They're gonna do the other one, compound interest. So this is if you want to borrow it from someone, okay, like an individual, usually. Let's look at this one. So what's given? Tell me what's given, if anything. There's the 4 letters. What do we know?
P is 540.
Yeah, P is 540. What else?
T is 85.
T is 85. Now T is the time in years, okay?
Mm-hmm.
So is it actually 85 or do I have to do something with that?
We have to do something.
How many years are there in 85 days? Gotta convert this into years. How do you convert 85 days into years? Well, you divide by 365 because there's 365 days in a year, or you multiply by 365. It's one of these. Which one do you think is right?
Divide.
Divide right here. Let me show you the unit conversion for this, the mathematical way. So we have days. We don't want days. We need to kill off the days. So days goes in the denominator, okay, like that. What do we want? We want years, so we're going to introduce years in the numerator. And what's the conversion factor? In 1 year, you have 365 days. So you're multiplying by 1 over 365, which is the same thing as dividing by 365, okay?
Mm-hmm.
So to go from days to years, you divide. If you want to go from years to days, you multiply. So 85 divided by 365. That gives me 0.23 years. What else do we know in this question?
R is 26%.
Right, so that's 0.26 and our unknown is A, yeah?
Mm-hmm.
So let's find A. The formula for A is P bracket open 1 plus RT. So our principal amount is 540 and 1 is just 1. R was 0.26 and the T we just found it was 0.23 years. So times 0.26 plus 1 times 540. So after plugging this in, I got $572.70. So this is how much the person will end up paying them back, yeah, after 85 days, okay? How do we find interest?
Okay.
So how much of this is interest? What do you think? He's gonna pay this much back. How much of this is he paying back just in interest?
You subtract the initial amount.
Yeah, exactly. Just subtract the initial amount. So 572.7 minus 540. You just get $32.7, okay? 32.7. So this is the interest amount. There's another way to do this. You can just do I is equals to PRT. This is the formula for interest. Or I is A minus P, depending on which one's easier. Well, here we could have done both, but this one's definitely easier. Okay.
Mm-hmm.
Does this make sense?
Uh-huh.
So you basically put money in a bank, which is P, or you borrow money from a bank, and over time, you earn interest or you have to pay interest, okay? You see that extra block here is the interest. That just grows over time, and this combined thing is A, your final amount.
Okay.
Same type of question, but it's a little bit different now. Okay, tell me what we know. I'm gonna give you the variables.
P is 4850.
Yeah.
And the rate is 7.6%.
What else do we know? It says how long will she need? Oh, this is gonna be our unknown, okay? This is our unknown. We don't know time. We're looking for time because it says how long. Do we know what A is?
The 8,000.
Yeah, because that's what it increased to, yeah? The 4850 that we had, it increased to 8,000. Cool?
Mm-hmm.
So look at the formula. It's going to be a little bit different. The formula is the same, but the math, the steps are going to be different. So we know what A is. A is 8,000. We know P is 4850. And we know R is that. And then time is missing. Now again, this is a linear equation. We're trying to solve for T. What do we do first?
Do you do the brackets last?
You can't really do anything with the brackets because they're not like terms anyways, like inside the bracket. But yeah, you'll do the brackets last. You want to kind of do the reverse BEDMAS here.
So you divide by 4850?
That's right. You divide by 4850. You'll get 1.65. Now what? We're trying to solve for T.
You subtract
Subtract what?
the 1.
Yeah, that's right. You subtract the 1. What's next?
You divide.
Yeah, you divide. So 0.65 divided by 0.076. So the time is going to be 8.55 years. Cool.
Mm-hmm.
Yeah, so sometimes R would be missing, T would be missing, or P would be missing. As long as you have the other 3, you can get the 4th one. Yeah, there's only 4 variables in this. As long as you have the other 3, you can get the last one by turning it into an equation. Something didn't work out. Let's see. Oh no, it did. 8 years and 200 days. Which we can find the 200 days actually. If it says exactly how long, you see we have 8 years, 8.55 years. Yeah, we know this means 8 years. How many days are there in 55.55 years? Question is, how many days are there in 0.55 years? And here's the conversion factor, right? How do you do anything? You can use this to literally do any type of unit conversion. I'm going to show you the thing again. This idea of unit conversions. You see, we have years. We don't want years, right? We need to kill it off. So years in the denominator because they cancel out. What do we need? We're looking for days, right? So we're going to introduce the days on top. And what's the conversion factor? We know there's 365 days in 1 year, like that. So you just simply multiply 0.55 by 365. If you do that, right, 0.55 times 365, you'll get 200 days or 200.75 days. Okay.
Okay.
So for this to happen at these rates, 8 years and 200 days.
Mm-hmm.
Let's look at the same idea. Okay, nothing fancy. It's just going to be a linear equation with the 4 variables. Nina deposits this much in a savings account. The rate of simple interest is 5.5% per annum. By how much does the amount in her account increase each year? So what are they asking us in part A? In part A, they're just asking for the interest. Okay.
Mm-hmm.
How do we find the interest? We know what the P is. P is 3,500. We know the rate is 0.055. Given these two, how do you find the interest? Well, you just multiply them, okay? The interest that you earn is just gonna be every year is gonna be PR. The interest that you earn over time is gonna be PRT. And if you add PRT with your initial principal, that's what A is, right?
Uh-huh.
So interest per year is just going to be P times R. So just multiply these two together. So 3,500 times 0.055. So the interest this person earns every year is $192.50. Part B, determine the amount in her account after 5 years. How do you do that
You
part?
just plug in T as 5.
Yeah, we can do that. So we know what the formula is. So 3,500, 1 plus 0.055 times T is 5 here. So 1 plus 0.055 times 5 and multiply this with the initial amount. So there's $4462.50 after 5 years. But it says at the end of each year, okay? So what we're gonna do is we're gonna make a table here. This is gonna be year, and this is gonna be the amount, okay?
Mhm.
So at the end of year 1, how much is there? Well, we know the interest every year is 192.50, right? So just add these two. After 1 year, this person will have 3,500 plus 192.50, 3,692.5 after 1 year. After 2 years, well, the amount is just gonna keep going up by the same thing. We're just gonna add 3,296 plus the interest. So plus 192.50, it's gonna be 3,885. What about year 3? What do we do? We're trying to find the amount in her bank account after the 3rd year.
You just add the interest to the previous.
Yeah, exactly. So 3,885 plus 192.50. That becomes 4,077.5. Fourth thing, same thing, just add it. It's gonna be 4,270, and then after 5 years, well, we already knew it. It's gonna be 4,462.50. Okay. So
Mhm.
you can see the amount is just gonna go up by the same thing gradually every year. Part C, state the total amount as the general term of a sequence. What does that mean? It just means this, you see this formula here?
Mhm.
But we don't know what T is. That's what that means, okay? So for that part, it's just gonna be 3,500 bracket 1 plus 0.55 T, and that's it. This will give you the amount after T years, and that's what this is asking us. Like a formula to use that you can find the amount after any years, what they are asking us. Graph this sequence. That one's gonna be a little bit trickier. You see on the right here, the A, we're trying to graph this, okay? You see this?
Mhm.
Any ideas on how to graph it? It's just a linear line. It's going to be straight. How do we graph this? Any ideas? It's a straight line. It's a linear line. It's a linear equation.
You start at 35,000.
That's good. All right, so I'll help you out. You just open the brackets if you can, because that's going to give you the slope. So I'm just going to open the bracket, and remember how to open these kind of brackets. Multiply 3,500 with this, and then with this. So if you open the bracket, you get 3,500 times 1, which is just 3,500, plus 3,500 times 0.55, which is 1925, yeah,
Mhm.
T. Okay,
Okay.
so what's the y-intercept and what's the slope? We're looking at this. Because to graph a linear function, you need the y-intercept and the slope.
The y-intercept is 35,000.
Yeah, it's 3,500. It's right here. What about the slope?
You go up by 1925.
Yeah, exactly. For every 1925 you go up, you go 1 to the right, yeah?
Mhm.
So it's gonna be 3,500 plus 1925. Well, that's 5,425. So you go up by 1925 and then you go 1 to the right, and there we go. That's the point. And then you just connect the dots. You just need 2 points to graph a linear equation. And there we go.
Mhm.
So this will give you the amount over 2 years, after 5 years, everything. The graphical way is not going to be very precise, so that's why we have the formulas. Okay, let's look at this one. Anita borrows some money. The amount that she owes at the end of each of the first 5 years is shown at the left. How much did she borrow to begin with is the question.
Could you just subtract like the first payment from the second?
We're trying to find P. If we do what you said, well, that's gonna help us. But is that gonna be P?
It's gonna be the interest.
Yeah, it's gonna be the interest, you're right. So this is what we get. Given this, how do we find the P?
You subtract the interest from the first amount.
Absolutely right, yes. So P is just gonna be 2081.25 minus 231.25. It's 231.25. So this person, Anita, borrowed 1850. Okay, that's our P. There you go. State the total amount as the general term of a sequence. Well, we know the formula is A equals P 1 plus RT, right?
Mhm.
But we don't have R, nor do we have T, right? Here's another formula for this one. Because here we're missing R, we're missing T. We can't use the 1 plus RT thing here. When it says sequence, okay, the sequence here, it works something like this. Yeah, this is gonna be some new numbers, but it's not gonna change anything. Tn means the y value of the sequence, okay? Tn is the y value. Or in other words, this is the amount after certain years, okay? After certain years. This is supposed to be D. Amount after n years. A
This
is,
looks familiar.
yeah, I think we have done this before, but it was a while back. A is the starting value. Okay, A is the starting value. N is the number of years. And D is the common difference, it's called. In this case, this is going to be the interest, okay? This is going to be interest, because that's what the difference is between all of these. So when it says state the general term, it's going to be Tn, okay, equals, what's the starting value, the principal value? It's 1850 plus, well, n minus 1, we don't know what n is, so we just leave it as that. And the interest was 231.25, and there we go. Okay. So how does this help us? So for example, we want to find the amount after 5 years. You simply plug n as 5. See, like 5 minus 1 times 231.25, and that should give you that 1850 plus 4 times 231.25, and yeah, there we go. Okay. So general term, it's always going to be in this form. Tn equals A plus n minus 1d. A is the starting amount, n is the years or whatever, and d is the difference, like how big of a gap is there from the first to the second. Let's look at C. How much time will have passed before Anita owes $7,500? So we want to find n.
Put that in as T.
Yeah, exactly. You plug that as in as T, and then you want to find n. So 7,500 is equals to 1850, yeah, plus n minus 1 times 231.25. There we go. Again, it's a linear equation. How do we solve for n?
You subtract 1850.
Yeah, that's right. What do you do after that?
You divide by 231.25.
Yeah. And then you subtract 1, yeah? Or add 1, sorry, you add 1.
Mm-hmm.
So you get n is 25 years. 25 point something years, but yeah, there we go. Okay.
Mm-hmm.
Still simple interest, but yeah, this is one of those questions where we didn't have the thingamajig, so we didn't have T, R, nor did we have R. Now this one's gonna be a little bit trickier. Len invests $5,200 at 3% interest, while his friend invests $3,600 at 5% interest. How long will it take for Dave's investment to be worth more than Len's? So what are we looking for here? Looking for time, yeah? How long? You see, it's in the question. The answer is in the question. So we're looking for how long. Yeah, we're looking for T, time, okay?
Okay.
And look at this. How does this work? So this Len guy, he's gonna start off with $5,200, yeah?
Mm-hmm.
And it's again, it's gonna go up, right? And the amount that it goes up by is the interest, right? He's gonna earn some interest. The formula for interest for 1 year is just PR. And then the other guy is gonna start off at 3,600. Okay, he's gonna start off at 3,600, but because he has a higher R value, it's gonna spike up a little bit faster. It's gonna look like this, see, like that.
Mm-hmm.
Question's asking us to find this time. Cool? So that's the goal. How do we do this? What do you think? We'll just use a simple interest formula, right? So for Len, the amount is gonna be, again, this is the formula. So for Len, we can just call this Y, I guess, or you can Y1, Y, because we're gonna have two different Ys. Call this Y1, we can call this Y2. So it's gonna be 5,200, yeah? Times 1 plus 0.03t. If you open this bracket, it's gonna be 5,200 times 0.03. So 5,200 plus 156t. So that's the equation for the first guy, okay? Similarly, for the second guy, the equation is going to be 3,600 times 0.05 plus 180t. And there we go. We have these two equations. Now we're trying to find the point of intersection between these two. Remember that? POI, point of intersection. How do we find that between two lines given their equations? We know one of them is going up like that, but the other one's spiking even harder. This one is Y1, this one's Y2. How do we find this point?
You add them and then.
You just equate them to one another, okay?
Oh.
To find the points of intersections, you literally just equate them. So you can just say Y1 is Y2. Okay, you see over here, the Y value is the same, right? Where they meet, the X value is the same, which is what we're looking for, but the Y value is also the same. So you do 5,200 plus 156t, and that's going to be equals to 3,600 plus 180t, like that. Points of intersections, you always just straight up equate them. How do we solve this linear equation for t?
I'm confused.
So we're trying to solve this equation for t, right? You understand that part? It's very simple. Just like terms. Think about like terms.
So you move the t's on one side?
Yeah, you put the t's on one side, so we're gonna dump this on the other side. It becomes 180t minus 156t. And we're gonna dump the numbers on the other side. 5200, easy as that, yeah? That's 1600. I believe on the other side we get 24t. So 1600 divided by 24. 180 minus 156 is 24, 5200. The answer here, T, is 66.66 years. Okay. What does that represent? What does that mean? What happens when T is this?
How long it take, like, for the person's investment to be more?
To be equal, yeah? No, this is when it's equal. You see, the Y values are exactly equal. But if it needs to be worth more, it's gonna be after 66.66 years. Okay. And exactly this, they're equal. Before this, the other guy is winning. Okay. That's a long time, the 66 years. Yikes. Now let's look at a different types of interest called compound interest. You know the difference, right? Compound interest is where you earn interest on the interest itself. Like let's say you earned $10 after first year, yeah? You're also gonna earn interest or 10%, whatever, on this $10. So you're actually gonna earn $1 from this, and then you're gonna earn other $10 from that as usual. And total you'll earn 11 bucks. So compound interest is where you earn interest on interest. Whereas simple interest, you don't earn interest on interest. You just earn on the principal amount. There is a formula for this. Let's compare the formulas. In simple interest, it was amount is equals to the principal, bracket open 1 plus RT, okay? Whereas in compound interest, because you're earning money on the thing itself, this becomes exponential. The formula is P 1 plus I to the power of N. I is still the interest rate, okay? It's just different notations. This is the same thing as it was. This was the equivalent of being R here. N is the same thing as T. It's just they just use different letters, okay? So compound interest, same idea, but a new formula, okay? Let's check this out. Lara's grandparents invested 5,000, and again, the question tells you, right? Look at this one. This one's telling us it's a compound interest. You see, compound interest. How much will the investment be worth on her 21st birthday? All right, ignore the word quarterly here for now, because that makes a difference. Okay, that makes a difference. We're going to do that next. So the formula for compound interest is amount is equals to the principal 1 plus I to the power of N. What do we know here? And what are we looking for? Which variables do we know and which one are we looking for?
P is 5,000.
Yeah, P is 5,000. What else do we know?
The interest
is what?
PR.
No. So that was for simple interest. Okay. You see this I represents in this, I represents the interest rate in decimals, which is what in this case?
$0.048.
Yeah, 0.048. And how many years? What's N?
21.
21 to the power of 21. Okay. Try plugging this in a calculator.
It's 1.
It's 1?
Yeah, or maybe I did it wrong.
There's no way that's 1. Let's do this step by step. Maybe try plugging this. So 5,000 times 1.048 to the power of 21. So first you want to plug this in, yeah? You got to do BEDMAS. So first do the exponent, and whatever you get, multiply that with 5,000. 1.048 to the power 21, do that first, and then multiply that by 5,000.
I got 2.676.
Okay, so you did the power 21, right?
Mm-hmm.
And now multiply that with 5,000.
It gives me a really big number.
How big?
Like 133,000 point something.
So it's 13,383, okay?
Mm-hmm.
This is the answer. So what does this mean? This is the amount in the bank after her 21st birthday, okay? If I asked you what's the interest, how much interest did they earn? The grandparents deposited $5,000. After 21 years, it turned into this. So how much interest did they earn on that investment?
You subtract that?
You subtract that, so minus 5,000. So over 21 years, they made $8,383.
Mm-hmm.
Okay. Did that make sense to you?
Yes.
All right, let's look at this question again, but now we're going to look at the quarterly thing, okay? The quarterly thing. Now, how does that change the question? It really does not. I guess it does. Compounded quarterly. So far we've seen the percent annum, yeah? So far we've only done this, but when it says compounded quarterly, how many quarters are there in a year? Or what does that even mean, quarterly? What's a quarter?
A fourth of something?
It's a fourth, exactly, it's a fourth. So when it says quarterly, what we need to do is, because this interest rate is for per year, yeah, you see that?
Mm-hmm.
We need to divide that by 4, okay? When this is quarterly, we need to divide that by 4. And we'll get the quarterly interest rate. So that's going to be 0.012, okay?
Okay.
And you see 21 years, even the time is going to change. So this one you multiply. Now, why do you multiply? Because you're getting interest every 3 months, right? 3 months. 3 months is a quarter year. So you're getting interest every 3 months. So how many 3 months are there in 21 years? Well, you just multiply that by 4. So 84. And that's how the question changes when it says quarterly or yada yada. So for this one, we're just gonna do it. Now it's just a plug and chug on the calculator. 5,000 times 1 plus 0.012, the quarterly interest rate to the power of 84, because that's how many quarters there are in 21 years. So 1.012 to the power of 84 times 5,000. So we get $13,618.62.
Okay.
Okay. There's a couple of these. So let's look at them in a little bit more detail here. So we did the quarterly thing, yeah? So when you do the quarterly thing, the interest, you divide that by 4, and the number of years, you multiply that by a 4, okay?
Mm-hmm.
There's another thing. It's called semi-annually. Now, what do you think this means? Annually means once, right? Yeah, semi-annually means twice a year, okay? Every 6 months. So you got to divide the interest rate by 2, and you multiply the years by 2.
Okay.
What else can they say? They can say monthly. What do you think we do in this case?
Do you?
Well, you're going to divide by something, you're going to multiply by something. How many months in a year?
12.
12. So you got to divide the interest rate by 12. then you'll get the monthly interest rate. You multiply the years by 12, so you get the number of months, okay?
Okay.
What else can they say? I'm trying to think. Weekly. Weekly is something they say as well. This one, I'm just going to give it to you. 52 weeks in a year. What else can they say? Bi-weekly.
What does that mean?
Bi-weekly is actually how you get paid here in Canada. Every 2 weeks.
Oh, okay.
Bi-weekly, everyone gets paid bi-weekly. So it's 26. They can also say daily. What do you think you do when they says daily?
365.
Yeah, exactly, 360. Okay, so if they say any of these, I mean, it's in the word, right? Quarter means 4, semi means 2, monthly means 12, weekly 52, bi-weekly 26. I've never quite seen these. They don't come as often, but quarterly and monthly, they come up a lot. Banks use daily, actually. Banks in real life, they do daily. Okay. So using that idea, let's try doing a different problem. So on our 15th birthday, Trudy invests 10,000. So we have two different people here. We have Trudy and then we have Lena, yeah? What do we know for Trudy? What's the P?
10,000.
10,000. What's the I? For Trudy.
0.08.
It is 0.08. Okay, that's the yearly, but how is it being compounded? Monthly. So what do we do with this 0.08?
You divide by 12.
Yeah, you divide by 12. So 0.08 divided by 12, and that is, I'm just gonna write this as a fraction for now, but it's not a nice number. 1/150. What about N? So they're putting it in their bank account up until they're 65. Trudy is 15 right now. So how many years till she retires or till she's 65?
50.
Yeah, 50 years. Again, what do we do with this 50?
You multiply it by 12.
You multiply it by 12, yeah. So 50 times 12, that's 600. Let's look at the other one. For Lena, what's her P? I guess it's 10,000, same thing. Her I is also 8% and it's compounded monthly, yeah? So it's not gonna change, it's gonna be the same thing. 0.08 divided by 12, which is a stupid number, 1 divided by 150. It's 0.0066. I can just write this. 0.0066, and it keeps going. I'm just gonna round it up. What about the N for Lena? She's 45 right now, and she is gonna keep it until 65. 20. What do we do with the 20?
You multiply by 12.
Yeah, you multiply that by 12, so 240. Cool. What's next? Which one do you think will have more money? Trudy or Lena? I'm gonna find the A for both of them, okay? Well, which one do you think will have more money?
Trudy?
Trudy, yeah, definitely Trudy, because look at them. P is the same, I is the same, but N is greater for Trudy, right? She's gonna keep it longer, almost like double, more than double actually. Yeah, because she's putting it for 50 years, whereas Lena is only putting it for 20 years. So Trudy will definitely have accumulated more interest over those years. So P is 10,000. 1 plus I is again not the 8%, but it's going to be this one to the power of n, which is 600, like that. Yeah. 1 plus 0.00667 to the power of 600 times 10,000. Oh, that's a lot of money. So Trudy would have had this amount of money in the bank after 50 years. Okay. Let's find Lena's, and you're gonna plug this in your calculator. So amount for Lena is gonna be P 10,000, 1 plus 0.0067 to the power 240. Why don't you try plugging this in?
It gives me 4.966.
Okay, what do you do with that?
You multiply by 10,000.
Yeah, that's right.
Yeah, 49,661.11.
Okay, there we go. So you see, this one doesn't even compare to this. This person has over 500,000. The other one is not even 50,000. Yeah. The question's asking us, how much more will Trudy's investment be worth?
Do you just subtract?
Yeah, you literally just subtract it. That's right. So 539.853.32 minus the number you just got. And we get 490,000. So this is the difference between their amounts. $490,000. Okay, $192.21. So the longer you keep it in the bank, you see, because the n values are exponent, yeah? The longer you keep it in the bank, the more money you get. But they will be lucky to have that interest rates. These are made up interest rates. 8% compounded monthly. Yeah. Imagine that you put 10,000 and it becomes 500,000. That's a good investment, right? But it took her almost 50 years though. The other one is more realistic. Where you put over 20 years, you get 50,000. That's more realistic. So this one, Nicholas spends $1,000 or invests $1,000. How long will it take for his investment to double for each type of interest earned? So what are we trying to find? We're trying to find the time, okay? The formula for simple interest is this. So what do we know in this case? We're doing part A first. Yeah, P is 1,000. What else?
R is 0.05.
What are we trying to find? Are we trying to find A or T?
T.
T. So we just leave T as T. What's going to be A? What happened? Look at the question. Investment to double.
Oh, so 2,000.
2,000, right? There we go. How do we solve this for T?
You divide by 1,000.
Right. So It's going to be 2 equals 1 plus 0.05 t. What's next? How do we solve this for t?
One.
You subtract 1, you get a 1, and then you want to divide by t, right? Or sorry, by that number, and that's going to give you 20 years. Prediction.
Yeah.
Compound interest, is it going to take us more time or less time for it to double?
Last time.
Definitely right, absolutely right. Because you're going to earn interest on interest. So now what's the formula for this one? A equals t 1 plus I to the power of n, yeah? What do we know? We're doing part B now.
P is 1,000.
P is 1,000, yes.
I is.
So it's 5% semi-annually. So what does semi-annually mean? What do you do with the 5?
You divide by 2.
Right, so you get 0.025, okay? Are we looking for N or A?
For n.
We're looking for N, right? Now, again, remember this, if you divide it by 2, whatever you do with the I, you gotta multiply the N by 2 as well. So it becomes 2N in the exponent, okay? And we're trying to find when the money doubles, and so the amount is gonna be 2,000. All right, how do we solve this exponential equation for N?
You divide by 1,000.
You divide by 1,000 and then you subtract, actually, I'm gonna leave that to you. Yeah, we can't get rid of the bracket here. 0.025 to the power 2n, there we go. Now what do you do? It's tricky, huh? We've done this though, we did this last time. What do we do when the unknown is in the exponent?
Do you do log?
You use what, sorry?
Log.
Yeah, you use log. When the exponent's missing, you use log. So the next step
Do
would
you
be,
bring it down?
yeah, so take
The
logs
exponent?
on both sides. Take logs on both sides first. 1.025 to the power 2n. And when you do this, the exponent drops down, yeah? So you get 2n times log of 1.025 equals log of 2. What's next? We're trying to solve for n.
You divide by log 1.25.
Yeah, exactly. So I'm going to divide both sides by log of this. So log 2 divided by log of 1.025, and that gives me 28. What's next? You divide both sides by 2, right? There we go, 14 years. So it took a considerably less time going by the way of compound interest. Okay, why does it go less time? It's because it increases exponentially. Look at this. We have something like this, yeah? The y-intercept is going to be the same because the initial deposits were the same, yeah? But look at this. This is when the amount is equal, yeah? See that? That's when they are both equal. But now if you look at this, let's say this is 1,000. This is 2,000 up here, yeah? 2,000. Look at the time. You see, maybe this is 10. Look at this, the time for this one to get the same y value, it's like 5 or whatever, 6. It's because it grows so fast, right? It goes so fast. That's why it takes less time looking at it from a graphical perspective. To get the same y value, it takes less x value. That's why it's quicker to go exponential. Okay.
Okay.
All right, let's stop there for today then.
All right, thank you.
All right, see you next time. Bye-bye.